Okay, so welcome again to this fifth PRAIRIE Colloquium. We are very, very thrilled and happy to welcome today Marta Ruiz Costa-Jussa. She's a researcher at Universitat Politècnica de Catalunya. Sorry for pronunciation, Marta. She works on language processing, natural language processing, and she has been awarded very recently, starting ERC grant about lifelong learning universal language representation, and she will present us today some of her work on multilingual machine translation, examining continuous learning and fairness. Thank you very, very much, Marta, and the floor is yours.
Thank you, Jamal, for the nice introduction. Thank you for inviting me. It's a pleasure to be here. Please feel free to ask questions during the talk. We can also ask at the end, but I appreciate if you ask during the talk, so feel free for that. And yes, as Jamal said, this is going to be a talk about multilingual machine translation, and I'm going to focus on two particular aspects that are how we can continuously introduce new languages into our system. So that's that part of continuous learning, okay? Not the part of adapting the language, but the part of adding new languages to our systems. And also something that is a transversal challenge in natural language processing and in artificial intelligence in general, which is fairness, and that our multilingual machine translations should also worry about. Okay. So first of all, a little bit of introduction. All the work that I'm going to present is not from myself, but it's part of our research group. I mean, it's thanks to our research group that we are currently growing, and I'm super proud. We are 2 professors at the UPC, 8 PhD students, and 3 masters and 1 bachelor. Master students and bachelors come and go, some stay, but still there is a lot of interest in these topics, and students are interested, and well, thanks for this, we have lots of opportunities to do a lot of, well, interesting work. Hope that you find it so. Then also about the funding that Jamal mentioned, I'm going to start this ERC starting grant just around the corner, next 1st December, okay? And what this scheme of funding promotes is frontier research that has to be done in Europe, and the idea is to substantially strengthen and shape the European research system. And well, now entering directly into our topic, okay, I want to first do an introduction, because I do not know how much the background of the audience, okay? So I'm going to start from the very basic concepts and then go into more technical ones, okay? So first, natural language processing, okay, mostly relies on these words embeddings. The idea is that, okay, we have words, but we want to use deep learning technology, so we have to transform these words into a continuous space, okay? And for doing that, nowadays, what we use is words embeddings that learn the distributional context of words and transforms these words into vectors, okay? More than that, we have the context words embeddings, for which we have a different representation of words depending on the context that they are appearing, okay? So it's not the same, the word play in the sentence I play football, that I attended to play in the big theater, okay? Because play, it writes the same way, but it has different meanings depending on the sentence, okay? That is it appearing. And contextual words embeddings are able to capture these differences. So I think there is one mic open over there or something. Okay, thank you. So contextual words embeddings, there are different types of building this, of learning these contextual words embeddings, okay? But it's normal to learn them with an architecture that it's called a transformer, okay? And the transformer is the type of architecture that learns with attention-based mechanisms that was firstly proposed for neural machine translation. Okay, so the idea is that for contextual words embeddings, we use the encoder of the transformer and we learn these intermediate representations that are the representation of words depending on the sentence that they are appearing. And the neural machine translation uses the entire architecture of the transformer that uses this encoder that learns an intermediate representation of the sentence that we want to translate. And from this intermediate representation of the entire sentence that we want to translate, we transform it with a decoder into the target sentence. Okay, so we are learning with this architecture of encoder-decoder. This neural machine translation system has allowed the quality of translation to increase by a big amount compared to previous phrase-based or statistical machine translation systems, okay? So now the gap between human quality and machine translation quality is lower than it used to be. Also, there have been big pieces of news that claim that we are at the human parity in machine translation, thanks to this neural approach. So the question is machine translation solved with the neural approach, with the transformer architecture, with the encoder-decoder, and so on? Well, neural machine translation has indeed some limitations in the sense that we are still learning from large amounts of data. So what we need is a lot of examples of sentence in one language and the corresponding translations in another language. And with this, what we have is a high quality translation when we have lots and millions of sentences that are the translation of each other. We have a high quality translation for these pairs where we have what we call supervised training. The same happens when we want to translate from speech to text. What we need in this case is the speech utterance and the corresponding translation. What happens when we do not have enough examples for this? The thing is that we end up with a low quality translation system. So, neural machine translation is usually trained on parallel data, and depending on the amount of parallel data that we have a better system or a lower system. This is to simplify things. Then how we can solve this issue? What happens when we do not have enough data to train our systems? There are current techniques that are the unsupervised techniques that we can learn from monolingual data, meaning that we have lots of text in one language, lots of text in another language. They do not have to match, they do not have to be the translation of each other. And we can learn the translation out of this corpora that it's not a translation of each other. So we call this unsupervised machine translation. And then another way to deal with this problem is to learn multilingual machine translation. No? So we want to transfer knowledge from high-resourced languages to low-resourced ones. Okay, in this talk, I'm going to focus more in the multilingual machine translation challenge to solve this problem. And let's try to make a historical perspective on this multilingual machine translation, a simplified one, okay? How we have dealt with multilingual machine translation within the corpus-based approaches. Okay, so when we built our systems with statistical machine translation, and we wanted to translate from a large amount of languages between them, for example, in the European context, we built pairwise systems, no? Meaning that we have to build a quadratic dependency of systems depending on the number of languages that we have. Okay, this is very expensive, especially in highly multilingual environments like the European one. Then another approximation to this multilingual machine translation, it was the idea of using a pivot language. Okay, so we go from the source language into a pivot one, and then from this pivot we translate into the target language. In this sense, the quadratic dependency in the number of systems lowers to a linear dependency. Okay, so we have less systems to build. And in the neural machine translation approach, initially we had also, when we wanted to translate between many to many languages, we had this pairwise architecture. Okay, but given the architecture of the neural machine translation system, that it already has this encoder that translates to an intermediate representation, and from this intermediate representation we translate it to the target language, we can go a little bit further than we did in the phrase-based system, and we can try to benefit already from this architecture and use this intermediate representation as an intermediate language. So we do not have to rely directly on a pivot language, but we can train this pivot language, okay, in this pivot representation. At least it has not to be a language, but an intermediate representation. Okay, and there are different ways of doing this. We can do it with a shared encoder and a shared decoder, so we can have a universal encoder for all languages and a universal decoder for all languages. Okay, or we can have independent encoders and decoders. Okay, that's what I'm going to show as follows. Okay, so the idea of having a universal encoder and decoder, it's very nice because we have only one system to maintain, but it has different drawbacks. Okay, so what are the specifications that we want in a multilingual machine translation system? Okay, so we want that our multilingual system is efficient in the sense that the less number of systems that we have to maintain, the better. We want to allow for zero-shot translation, meaning that if I have trained in my system English to French translation, and I have trained French to Romanian, I want my system to perform translations between English and Romanian, even if I do not have trained these pairs of systems. This is what we understand for zero-shot. Then we have a totally unsupervised zero-shot in the sense that I do not have parallel data. I have one language and I do not have parallel data with any of the languages in the system. So I want to be able to add this language into the system. I want my multilingual system to have a transfer learning. Okay, what I mentioned before, that low resource languages can benefit from high resource languages. I want my system to be able to continuously add new languages without the need of retraining the entire system. Okay, so I have my system trained for I don't know, n languages, and I want to add a new language into the system, and I do not want to retrain all the system again. And finally, I would like also to deal with multilinguality. So I want to translate speech and text. And well, these are the main technical specifications, but the transversal ones are that okay, I want my system to be fair. We are going to talk about this in the second part of the talk. Okay, what does it mean to be fair? for the particular case of multilingual and for the particular cases that the community has pointed out. And then also I want my system to be interpretable, okay? That it's one of the big issues also of the deep learning techniques, okay? That sometimes we do not know exactly how to explain certain outputs of our systems. So, okay, so here we have how our specifications match with different possible multilingual architectures that we have, okay? We have this shared architecture that I mentioned, that you have a universal encoder and decoder. So in this architecture, it's very efficient in the sense that I have to keep only one translation system, a big one, but only one. And I can do transfer knowledge from high resource languages to low resource languages. Whereas there is this alternative architecture that is similar to the one that I showed, the pivot approach, okay, that we have encoders for each language, an intermediate representation, and then decoders for each language, okay? So I have one encoder for each language and one decoder for each language. This architecture has the advantage compared to the shared one that I can add new languages without the need of retraining the entire system, okay? It can deal with different modalities, and we can train also totally unsupervised zero shot. So the idea of the lunar starting run, okay, the one that we are about to start, is that we want to make that sentences that mean the same thing, no matter if they are speech or text, they have the same intermediate representation in our architecture of encoder and decoder, okay? So we want to make this universal language representation both for speech and text. And this what is the impact of having this intermediate representation? The idea is that when having this intermediate representation, we can add new languages without the need of retraining the entire system. We can add new modalities, speech if we have trained our system with text, and we allow for zero shot, okay? So these are the advantages of this. And the final system would be something like this, where we have many source languages, speech and text. We have the intermediate universal language representation, and we can translate to any language, textual language, okay? And we want to enrich this intermediate representation, make it better by introducing different type of resources, not just parallel text or parallel data, but also monolingual data, also linguistic resources that are available in many languages, okay? So like the universal dependencies and all these things, BabelNet and many resources that are available for a large number of languages. Okay, so how do we train this modular architecture where we have one language, one encoder for each language and one decoder for each language? So it looks a little bit like this. We train all the languages that we have in our initial system. Let's imagine that we have 4 languages from L0 to L3. So we train all translation directions. And you may say, okay, this looks like a pairwise translation because at least we are training all the language first. But here the main difference is that we are training the encoder for language 0 is the same one when I'm training language 0 to language 2, or language 0 to language 1, or language 0 to language 3. Okay, so the encoder, the parameters of this encoder are shared in the 3 translation directions, okay? And the same for all the other encoders. So I train one encoder for each language and one decoder for each language. So in this sense, it's different than the pairwise bilingual translation. And then when I want to add a new language, so I have trained my initial system and I want to add a new language, in this case, L4. And let's imagine that I have parallel data of this language 4 with language 0, for example. Then what I do is train this new language, the encoder of this new language, with the frozen language 0, okay? And by training this, once I have trained it, I allow for zero-shot translation with all the other languages in the system, okay? And the same the other way around. When my new language is in the target site, I do the same. I train from language 0 to language 4, and I frozen, in this case, the encoder of language 4 that it was already trained in the initial system. And I have this zero-shot translation with the rest of the languages in the system. So this system that it's trained, imagining initially for textual language, I can also add a speech. And the first thing that we have done in this direction is to train an end-to-end transformer for a speech translation, okay? And in that sense, what we have, the main modification that we had to do is to allow the encoder to deal with speech, okay? So the architecture of the speech varied a little. Of the speech encoder varied compared to the architecture of the encoder of text, okay? Obviously, because speech is much longer than text, so you have to deal with this length input that it's much different than in the text case. And then also mentioning what I already said about adding linguistic resources. So what we have done at the moment is we have used a factored transformer to introduce linguistic resources that in the future might help to find a better intermediate representation for all languages. And we have built this factored transformer that allows to add part of speech tags, dependencies, syntactic dependencies, BabelNet tags, BabelNet information, and so on. And then what we have done in the direction of adding totally unsupervised data, only monolingual data, okay? Because let's imagine that we have this situation for which we have a new language, but we do not have parallel data from this language to any of the languages in the system, okay? That would be at a new language, totally unsupervised in our system. So we have yet not achieved, not tried this situation, but what we have done is work in the direction of adding a new language that have very few parallel data with one language in the system. And we have then additionally added a lot of monolingual data from this language that we are adding into the system to improve the translation of this language with the languages already in the system. And in this sense, what we have done is in 2 steps. We have built a first version of the translation system with a few parallel data that we have, doing a supervised pre-training as I showed before, and then a second step of unsupervised fine-tuning, adding monolingual data to improve this new language that we are adding, okay? And then this is the part of the multilingual architecture that we are dealing with, that is this independent language encoders and decoders for each language, and that we are working in different directions to add unsupervised data, to add linguistic information, to add speech. We have already, I do not mention here, but we have already a paper in arXiv that we have submitted to a conference that is allowing to introduce speech and allowing for zero-shot speech translation for the first time, thanks to this architecture, okay? And well, now I want to change a little bit the topic and move towards fairness, okay, in machine translation. And first of all, let me do this introduction. That it's that currently our systems have this problem that they behave differently for different, depending on the target that we are using our system. Okay, so for example, systems that recognize faces work differently for people that have for American faces or Asian faces, okay, in the sense that they perform much better for American faces because they have been trained with images of American or European people, okay, so they perform better in that sense. We have the problem that systems, job selection, systems that allow for doing automatically a job selection, okay, prioritize less qualified male over more qualified female, just because in the past they have been trained, well, they have been currently trained with data from the past where most employees in that position were male and were not female, okay, and more at the task level in NLP, for example, we see that words embeddings that we have talked at the beginning of the talk relate computer programmer to man and housekeeper to woman. Okay, so that the bias that we get, it's at the very bottom of our, at the very core of our systems. Okay, in the sense that our words embeddings, for example, already are biased and amplifying stereotypes that we have. And machine translation does not escape from this problem, so we have it. And here on the right in this slide, you have an example, okay? So the second sentence, I do not speak Malay, but this is a translation from Malay to English. And in the second sentence, what we have is, Jezeline is a female. He works as a programmer. So here we see the stereotype that we get in the words embeddings is also present in the final translation system, okay? I'm saying that Jezeline is a female, but still the system says that he works as a programmer. It should be she works as a programmer. But the stereotype is so strong that it does not, the system learns to ignore that the core reference here and does the mistake of choosing he instead of she. Other fields have been already in this have already faced this problem. Okay, so we have healthcare that did clinical trials only with one part of the population. Okay, so standard male, I don't know, 80 kilos, whatever, some very standard part of the population, and where the medicines that were done in these clinical trials were used for female or were used for kids or were used for all people, provoke different reactions and cause very a lot of problems. Okay, and this is going better in healthcare, and what they are doing is doing a diversity of clinical trials to to focus on different parts of the population and be better, have better solutions for different profiles. Okay, race, ethnicity, ages, gender, everything. Okay, so well, we have to get inspired by these fields, and what we have to be aware of is that we are learning from data sets that are not diverse enough or are unbalanced. Okay, so here we have an example of the males mentions in book descriptions and the female mentions, and we see that the mentions to females is much lower than the male mentions. Well, they should be, if we take into account the population distribution, it should be 50-50. Oh, I don't know exactly, maybe not 50-50, but anyway. So here in this topic of fairness machine translation, we also are looking at the specifications that we want in our system, and we want our systems to be interpretable, okay? We want to know why they choose their outputs. We want to be able to explain this, and we want our systems to be transparent. So we want to know, we want to show users and our funding agencies what are we training our systems with. So okay, so we have to be very clear of our data, where what to make them transparable, document them, and show nice statistics of them that might be relevant. And then we have to look for equity. Okay, so we have to allow our systems to perform in a comparable way for the population, okay, for the different users that we have. We cannot allow that our systems perform super well for one part of the population. I mean, this is not equitable, okay. And then I'm going to explain now some of the works that we have done in this direction. And one of them is we have worked towards interpretability, okay? So in that sense, we are visualizing our intermediate representations. In this case, we are visualizing the contextual words embeddings of different words in different sentences, okay? So I have this example here at the top of the slide. You have the link of our demo in that you can use these visualizations, and also what you can play with them, and you can also use the code to visualize your own trained systems. And okay, so we have these sentences. What we have seen with these intermediate representations is we have this sentence, for example, I've known him for a long time, my friend works as a personal financial advisor, and we have the feminine version, okay? So the sentence is totally the same one, except that we are using male or female, okay? So the meaning of the personal financial advisor is the same. So in this sense, the contextual word embeddings should not change, okay? And it does not. So here we have on the right the places where advisor in the male sentence appears and advisor in the feminine sentence appears. So it goes to the same point in the space. It has the same representation. Whereas in this case, the sentence is the same but with different words, and it only changes male or female again. But here we have different representations of financial in the male sentence and financial in the female sentence. Okay, so it seems that here financial, it does have a different meaning for the algorithm, okay? And manager, it has as well. And here what we see is that, well, what we imagine is that manager is more associated to male than female, and whereas advisor is not the case, okay? So here we see that our system behaves differently, okay? It has a little bit, we think it's stereotyping. Then what we have done towards the work that we have done towards equity is working on a multilingual parallel data set with this gender balance, okay? As I mentioned, our data sets have more representation of males than females, and this happens for the monolingual data sets, but also for the parallel data sets. And the problem is that the parallel data sets are not as easy to find as the monolingual data sets, okay? So that's why we have tried to, well, we have this toolkit that it's called GeoView toolkit that extracts multilingual parallel data from the Wikipedia okay, that it's balanced with the same number of female representation and male representation, okay? And we have used this balanced data set that it's available. You can use the toolkit. You can also, there are some already built corpus. We have used this balanced data set to fine-tune our machine translation system and to mitigate the bias that we have in machine translation system. And really fine-tuning on this balanced data set allows for reducing, mitigating the gender bias in machine translation. And finally, towards transparency, what we have done is extending the already initiative of the of data sheets for data sets. That data sheets for data sets, it was a very nice initiative that tried to document data sets in machine learning in general, okay, specifying different relevant parts of the data sets, okay, in the sense that, okay, when in fact the inspiration was taken from the chips that have their data sheets, okay, that you know what a lot in those data sheets you specify that the characteristics of the chips. So it's the same but done for data sets, okay? So we specify the origin of the data set, if it's open source, if it's not open source, or who is the agency that collected the data set, and many other things, okay, that allows to be transparent, what I was mentioning, with our data sets, that it's a very relevant part of our systems, okay? At the end is what we are training our systems on. And the idea of these empty data sheets is that we are adapting the data sheet that was general for machine learning, we are adapting it for the community of machine translation. And we have this repository, okay, that now it's been extended with some forum that we want to interact with the community so that we can modify this, the one that we have proposed, to adapt it to the requirements of the community, okay? So the idea is to do documentation of our already created data sets that we have a lot in machine translation, okay? And to do a little bit of documentation to learn about our data sets. So I'm concluding now, and the thing is that, okay, so that the project that we are about to start will highly impact at the levels of efficiency, quality, multimodality, adaptability, and equity in speech and text translation, okay? So we want to face this problem of having low resources in machine translation, okay? And for this, having lower quality in our systems, okay? So we want to achieve that more or less similar quality for all the languages well, all the languages, or most of the, well, not most, for a large amount of languages, okay? Because I mean, we have too many languages in the world to deal with, but still. And beyond translation, this impact will also be in multilingual and multimodal language processing applications, okay? Because in learning this intermediate representation, we are allowing to do multilingual question answering, information retrieval, sentiment analysis, chatbots in a more efficient way. And obviously, all these will focus in building fair systems, okay? And the motivation of having this present, this all the time while we are working, is that unconscious bias can be really harmful. In the bias in computing, we might be helping in the biasing society, okay? And in taking care of these social biases, we are taking care about the accuracy of our systems, okay? And the tools that we have to deal with this is, okay, we can build or we can train or use balanced data. We can use algorithms that generalize better So in that they are detaching from this data that is biased. And of course, we have to do a work in evaluation. So evaluating our systems in a way that we see that it's totally representing the population, okay, not just a part of it. And we have to work at the human level in the sense that this has to be elevated. I mean, this has to be something in the agenda of the governments, okay? We have to have laws that check that our systems are fair at the social level, okay? We have to organize diversity workshops. We have to improve the education of future generations, that they are aware of this. We have to include ethical subjects at the university, and even at the school level, we have to do work on this direction. So it's something that our community is not capable of solving alone. So this is a social problem, okay, and this is a cooperational work. And well, thank you for your attention. Thank you for being here, and I'm happy to have questions.
Thanks a lot, Marta. Thanks for this clear presentation. Okay, as you said, it's time for some questions. Well, we have already a question on the chat from Olga, I think. Well, the question is, what is the difference between human translation and perfect translation?
Yeah, thank you. I have to change that graph. I mean, it's totally misleading. I mean, yeah, I mean, translation is very complicated, okay? And this comes, the difference between human translation and perfect translation comes from the fact that even humans, we do not agree in the quality of translations, okay? So even a human translation can not be perfect in that sense, okay? Because I mean, it's a very complex problem, and there are cultural things, and I don't know, for example, a very simple example in the sense that Brazilian people say that, how do you say? I cannot remember that. A word that it's nostalgia in Spanish, but it's not really nostalgia. Saudade. 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 It has no translation, no? I mean, I translated in Spanish, but they at least when I was, I mean, what I learned is that they mentioned that there is no translation for that word, okay?
There's no translation for saudade, yeah.
So that's why, I mean, that's the difference between perfect and human translation.
Okay, great. Well, I think that Olga reacted on the chat.
Thank you for saudade. Yeah.
Well, maybe you can directly ask the question, Olga.
Okay. Olga is saying.
Oh yeah. Well, the question was also because in the charts you showed, it seems to me that some languages had really lower human performances than others. So I was wondering how is that possible that, yeah, for something like Chinese, the human translation is so much lower? Is it because it's more difficult or something to translate to Chinese, or yeah, that one, yeah. English Chinese is particularly bad, and Chinese English.
Exactly. Is the yeah. In fact, the other day, talking to a psychologist and neurologist, mentioned that even if we think that English, Spanish, English, French, at least for me, okay, it's super different. The origin is the same, okay? They are linguistically.
Yeah, I know, but
exactly.
Why is the human translation so far away from the perfect translation, or is it because of the proficiency of the translators?
Then you are raising a nice question. I'm not sure I should, I mean, these graphics from Google, I should go back and see if what do they, oh, sorry about this. Why do they mean about these things real? But it makes totally sense what you are saying here. So maybe it's related to the human proficiency, that we have less proficient translators between Chinese and English. Also influenced by what we are saying, okay, that Chinese and English are more are much distant languages compared to French to English, so the disagreement in quality might be bigger because of that.
Okay, thank you very much for your answer and your presentations.
Thank you, Olga.
So we still have room for other questions. Do not hesitate.
So maybe a naive question, but what are the typical way to measure performance in translation? And is it something that is
yeah,
I don't know anything about the field.
Yeah, I mean, we have mainly, there are two ways, okay? So to optimize our systems, we usually use an automatic metric that it's BLEO, okay? That it's basically we have our translation output and we have a human reference, okay? For the gold standard, we have a human reference and we compare our translation output to the human reference, and we the measure is higher the more words that our translation output matches with a human reference, okay? And not just unigrams, but also bigrams, trigrams, okay? So sequences of words. The longer that our sequences match with the human reference, the better is scored our translation, okay? And this is the typical one. It has flaws, whatever, but the community agrees in comparing these our systems with this. And I think that it's even if it has flaws, and a lot of people is criticizing it because, for example, it does not take into account synonyms or whatever. So it has a lot of things it's simple, and it allows our systems to compare, and it has allowed the community to progress, that it's progressing at a really fast pace, okay? And then from the other side, and totally different, apart from the alternative automatic measures that we have, okay, there are plenty of them, we have the alternative of human evaluation, okay? So we use humans to, okay, they have the output, they have the source sentence, or sometimes the reference sentence, depending, okay? And they evaluate the adequacy, the fluency of the translation, okay? But this is much more expensive, and of course, we are not optimizing our systems with manual evaluation. We are just testing, and it just normally used in international evaluations, for example, that our systems are scored in a manual way because it's very expensive.
But I have another question. Yeah. Okay. So, well, one of the main challenges is to deal with low resourced languages. So you mentioned some of them. So how your system deals with very low resourced languages such as dialects, let's say, very low resource languages.
Yeah, so it was the case it was the case that I showed that we are starting working in with this case of Tamil. In Tamil, now I cannot remember the exact pairs, but it was it's an extremely low resource. So in this case, what we are starting with is this. We have very few parallel data sentences, and we train an initial system from which we can already produce some translations of very bad quality. And then we imagine, I mean, BLEO score goes from 0, the percentage BLEO score that I was mentioning goes from 0 to 100. And And here in this case, we had like 4 ble or something, which was very low quality. But then with monolingual data of that language, we can improve our system like by 6 point ble or 7. Okay, so one way is that using the few data that we might have and the monolingual data, and another way is using linguistic resources, okay, that might be available. And the other way, if it's a dialect and we can use similar languages, is another way to improve that that pair of languages. Okay, there are different strategies.
Okay, thanks. Well, if there's no other questions, I have another one about fairness. How do you measure fairness? Well, there is a growing interest on defining fairness in machine learning. So from your presentation, I didn't see a metric of fairness. So how can you measure that?
Yeah, great question. And I haven't added here. But nowadays in machine translation, at least, we have a way to evaluate not fairness, which is very broad, but we have a way to evaluate the gender bias accuracy. Okay, so there is this WINO MT, WINO machine translation data set, okay, that it's a data set from English, okay, that it contains and it encodes several stereotypes and co-references, like the example that I have shown here, okay, that we have a co-reference and we know that here he should be she. So a type of, it's a synthetic one, a synthetic data set, okay, so the constructions are very fixed and artificial, but at least they are controlled in the sense that it's exactly what we want to measure, okay? And with that said, is what we have evaluated this approach that I mentioned here, that I said that we are mitigating gender bias, in the sense that we have this measure of accuracy that allows to see how well we are doing in reducing stereotypes, okay? In reducing, for example, we know bias is centered in the professions, okay? So, for example, nurse is highly attached in English, is a neutral word, and in Spanish it can be feminine or masculine. So it tends to translate to feminine because there are more nurses that are females. And in that sense, we are measuring the accuracy of this translation. So we have a synthetic, that the answer would be, in the case of gender bias in machine translation, we have a synthetic data set that allows to evaluate the accuracy on this particular problem, that it's binary gender bias thing. So it's very particular. It's not evaluating fairness in general, okay? But the problem is so big that we have to start little and
yeah. Okay, thank you.
Thank you, Jamal.
Well, we have another question on the chat. Well, go on, Olga.
Yeah, so I was wondering whether you have some intuitions about what something like coreference or anaphora resolution could mean for this gender inequality problem.
Yeah, thank you, Olga, for the question. It's a very interesting one, and in fact, it has been already approached, this problem. It has been, like you are saying, so it has been some coreference systems have been integrated in the neural approach. Okay, so for example, one approach has been to, okay, I can use a coreference toolkit to tag where my entity refers to, okay, like a pre-processing, and then do the translation. Okay, this has been already done, and it improves a little bit the problem of it mitigates the gender bias thing. Okay, obviously you have to deal with the errors that coreference tools have, and Well, it has been done. Nowadays, it's not standardized. Okay, so it was one word that it's there. Okay, and it helped because already the transformer architecture is powerful in the sense that it can get sometimes this coreference only when the coreference is present in the sentence, because one of the big problems of machine translation, and this is a big one, is that coreference translation is dealt at is faced at the sentence level. Okay, so if you do not have the context in your sentence, you cannot know the gender of your entity sometimes. Okay, so that's why we are moving, the community is moving, and this makes more sense, and I think it will permeate us. So I think that we are little by little moving to that direction. Is moving at the translation of document level. Okay.
Yes, it makes sense, and I also think that the gender inequality in terms of amount of data is also present for data that is used to learn coreference tools.
Exactly.
So somehow it's the same problem, but I was wondering whether you looked at that.
Yeah, in that sense, there is this gap corpus, Mind the Gap, no, that tries to address this problem of the corpus. I mean, it's a balanced corpus in coreference resolution. So that the same thing that we were doing here, well, differently, okay, but anyway, the idea of balancing our corpus in that sense, Mind the Gap, it's called Mind the Gap, the paper. It's a paper that it's a coreference and it's balanced in gender, addressing this issue. Yeah.
Okay, thank you.
We have another question on the chat from Ioannis. So it's a long question. Maybe I'll let you just read it, Marta.
Okay, so Ioannis' microphone is not working. So regarding the multilingual system, have you maybe tried to also have a universal shared encoder and decoder apart from the language-specific ones, so that the output of the language-specific encoder connects to a shared encoder to get the universal representation? This would trade some flexibility for memory, but might also benefit very low resource language translation. So, Ioannis, if I get the question right, is I have my language independent encoders and decoders, or language specific ones, and I additionally have the universal encoder and decoder. So I have both. This is interesting.
Yeah.
This is interesting. I have not tried it. What I'm thinking is which output would you? I mean, because I mean, you have two systems to. So the idea would be to unify both, and you have two encoders, for example, that translate the same language, and two decoders that translate the same language. And then you should do a combination of that, no? I mean, it's an interesting question. I have not tried it, and I should think on the benefits of such a proposal, because it's true that computationally it's expensive, okay, because you have to maintain this huge shared language encoder and decoder together with the language specific ones. But still is interesting, and thank you for the question, and yeah, I mean, at least it's I think it's very worth thinking on the advantages that this could have. Thank you.
Yet, speaking about resources, computational resources, what kind of computational resources you use? Do you have supercomputers in Spain? How do you deal with that?
Yeah, I mean, we have in the group, we have a cluster of 40 GPUs, but to train this English, this language specific encoders and decoders, we typically are training, nowadays we are training still with 4 languages, English, French, German, Spanish. These 4 languages, and adding Russian, Tamil, and things like this. And to train these systems, we use only 1 GPU. We are training with the Europarlament, with the Europarl, okay, that is typically 2 million sentences per language, okay. And I mean, this is not a huge database. It's not a small one, okay, but it's not a huge one. And we are training with 1 single GPU for each training that we are doing. So in that sense, we require the same amount of resources that a bilingual system in neural machine translation requires, okay? Because doing our joint training is iterative, okay? So we need more time, okay, but the same resources.
Okay. Well, if there is no other questions, it's time to warmly thank Marta. Thank you very, very much for the presentation and this question and answer session. Well, and we wish you all the best for your work, and thank you again.
Thank you, Jamal, for the invitation, and thank you all for the questions. I really appreciate them. Thank you.